Okay, so f of 3 means we're going to plug in 3, 1 over, are we plugging it into f or into f prime? Into f, or I guess in our case it's p, right? So we should do natural log instead of 3 plus 2 minus p of negative 1, so natural log of negative 1 plus 2. Any questions there? All over, what is 3 minus negative 1? 4, right? Squiggle, squiggle. 3 plus 1 is 4. Equals 1 over c plus 2. Our goal in all of this is to try to find the value of c, because since we said it was continuous on the closed interval and differentiable on the open interval, there has to be at least one c where the tangent line slope at that point is equal to the secant line slope. So we're trying to find that c. Okay? So how would you go about finding c?
Match the top of the other side with 1.
Well, it'd be nice if there were no fractions, wouldn't it? That would be nice.
We just like mono 5 and mono 1.
Could we, okay, let's simplify the natural logs really quick then. C plus 2 equals natural log 5 minus natural log 1 over 4. That already looks a little bit nicer. We're trying to get c by itself.
So would that be ln of 4 over 4?
Yeah, you can't subtract those like that. Okay. What's the natural log of 1? 0, right? That's where it crosses the... So this one is just subtract 0, so it becomes 1 over c plus 2 equals natural log 5 over 4, because that one is 0. Solving for c's in the denominator. You need to get it up top to the denominator. So you need to... Yep, we need to multiply c plus 2 through both sides. Make sure you're careful on, don't just do steps in your head, because that's where you can easily make an error. And also, people can't just follow what you do in your head if you want partial points. Okay, now c is in the numerator, that's good. How do we get it by itself? Yeah, take the reciprocal of that 4 over natural log 5. 4's cancel, natural logs cancel. Make sure you do it on both sides. 4 over natural log 5. So we get 4 over natural log 5 equals c plus 2. So just subtract 2. Minus 2 equals c. Okay. What does this mean? Yep. So if this was my graph, whatever the decimal 4 minus natural log 5 minus 2 is, that would be your x value, where the tangent line would be the same from, what was it, negative 1 to wherever 3 was. It will be the same, so it will be parallel. 4 divided by natural log 5 minus 2, it's approximately 0.49. So like right there, you'd have parallel. Okay. Okay, let's try the last one here. You want to try it by yourself?
Yeah.
Yeah? Okay, try it by yourself. Let me know if you get stuck. And make sure you get it in the setup that is in the definition. We need the derivative of c, f prime of c, and we need the average rate of change equal to each other. Done? Okay, that can break down.
Try it.
Mhm. Or differentiable out in the open interval, was that your first instinct? Make sure you always check that first. This one works, but make sure you check it. If you don't, then there's no reason to go through all this hassle if it doesn't work.
Now, if it isn't continuous, or it doesn't meet that criteria, could there still be a tangent equal to the secant?
Mm-mm. Because, like, say it's not differentiable. You have something like this, not differentiable. It is continuous, but not differentiable. What's the slope of that point? Oh, we don't know. It's undefined. Because approaching from this way, it's positive. Approaching from that way, it's negative. Doesn't really work. Okay, are you ready to go through this? Maybe another minute? Probably. You didn't look at a specific case. It ends up being just that, but talk about it in a minute. Don't do decimal. And remember, if you do a decimal, you're rounding 4 decimal places. Okay? But we don't need a decimal in this case. Yeah, you can either do you do quotient? You can do quotient rule, it just takes longer. Alrighty, so first of all, what does this function look like? What's the parent function? Yeah, the parent function is y equals 1 over x. You remember what that graph looks like? Curvy, curvy. Okay. The minus 6 is a multiplier. What does a negative multiplier do? Flips it. So now we're like this. And what does the 3 do? Up 3. It's a vertical shift. If it's inside the function, it's a horizontal. So like here's a quadratic. Same thing would apply to our rational x minus h. If it's inside the function, horizontal shift, vertical shift, opposite, same. Okay, so we have, it's going to go up 3. 1, 2, 3. So we'll have an asymptote. Okay, so from 3 to 6, is it continuous? From like, say, there to there. Is that continuous and differentiable? Yeah. If we had said 0 to 6, it wouldn't work. Because, I think we have an example of that, right? This one, right? From A to B, because we have it's not a closed interval. Okay. So, we can take the derivative. You can do the quotient rule, which takes a little bit of time. It does work. Or you can, the easier way is moving that x up. So, f of x equals 3 minus 6x to the what power? Negative 1. When we do a derivative, it'll become negative 2. So, f prime of x equals negative 6 times negative 1 will be positive 6, x to the negative 2. Did you all get positive 6? If you didn't look at that 6 being negative. Okay, so f prime of c equals 6, c to negative 2. That might be a little confusing to work with. 6 over c squared is equivalent. Questions there? Okay, so we have 6 over c squared, that's f prime of c, has to equal the rate of change. F of, what's b? 6 minus f of, what's a? 3 all over 6 minus 3. Any questions so far? So we have 6 over c squared. F of 6, remember, you're using the original. Now, I guess you could choose that one. Actually, it was going to come out nicely because 6 over 6 is going to be pretty nice. 3 minus 6 over 6 minus, put this in brackets because you're subtracting everything. 3 minus 6 over 3 all over 3. 6 minus 3 is 3. And just simplify. 6 over 6 is 3 minus 1, which is just 2, minus 3 minus, what do we have here? 2, which will be 1, all over 3. So we get 6 over c squared equals 1/3. Okay, solving for c. What do you do to solve for c? Multiply by c squared. Yeah, you could do that too. C squared, cancel, cancel. So we have 6 equals c squared over 3 times by 3 times by 3, cancel, cancel. 18 equals c squared. Okay, is there currently a square root on the paper? Is there currently a square root? No, we apply the square root ourselves. Some people I saw this, and some people I didn't. When you apply the square root yourself, how many answers are there? 2. Plus or minus? Plus or minus square root 18. We can break down square root 18. 9, 2, 3, 3. Are there any pairs? Yeah, pull out 3, so it becomes 3 root 2. However, equals c. However, we have a closed interval from 3 to 6. So one of these isn't in our closed interval. Which one's not in the closed interval? The negative one is not in the closed interval. So you just happen to be lucky and choose the right one on accident. Positive root 3 over 2 equals c. That's the one that's in our closed interval. Applies to the condition. If we had done it at a wider interval, we could have had like these two, right? Well, I guess our rate of change would change because our a's and b's might be different. But, okay, mean value theorem. Any questions? All right, we're going to go through this worksheet and get together with partners, and I might have to look through it and see if there's anything you can't read. Maybe I'll keep this one, because the day I copied this was the day the good printer was broken, so I had to use the old printer, which kind of copied light. I think you can see most of it, though. Is there anything on there that you can't? Oh, maybe the graph. Maybe I'll show you what the graph is supposed to look like. The graph on the back side.